Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 34 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Elite Explorer Kit. Now, most of you guys probably already have your gear, but if you don't, look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 33. But first, I must ask, were you successful with the homework? If you were successful, leave a comment down below. I am legend. And if you're not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay, hopefully you guys got this because it's really just reinforcing the learning that we've done in the earlier classes in this video series. And so hopefully you were able to pull those things together and to get it working. What the assignment was to put some sort of visual display for the brightness around the Arduino. So something like one display for a very bright sunshiny day or a cloudy day, partly cloudy, down to nighttime, and somehow visually display that with your Arduino. One possibility, maybe you could turn an LED different colors, or you could have different LEDs in a bar graph sort of setup. What I chose to do was to display it on the servo, and that's the solution I'm going to show you. I'll be eager to see the solution, the other solutions that you guys came up with. Okay, way too much talking. Let's jump over here and I'll just kind of show you my physical setup. I'll get out of your way, and then I'll come over here and kind of show you my physical setup. So what I have is I have the servo. I have a little indicator arrow on the servo, and then the servo can point to bright sunshine, partly cloudy, or nighttime or moonlight, like that. Okay, that is the setup. And let's talk real quickly about my circuit setup for that. And we can do that by coming over here to the sketch pad. There's kind of two parts to the circuit. There are two parts to the circuit. The first part is over here, and that part is the photodetector. So I have the top leg of the photodetector connected to 5 volts. I have the bottom leg of the photodetector connected to pin A0 on the Arduino, the analog in pin A0, and the top leg of a 10,000 ohm resistor, a 10,000 ohm, or you could call it a 10K ohm resistor. And then coming down here, the resistor goes to ground. Over on the servo side, the servo has 3 wires, red, orange, and brown. Brown is ground, so I've got the brown wire connected to ground. I have the orange wire connected to Arduino pin 9, and then I have the red wire or the power wire connected to Arduino 5 volts. Okay, hopefully that makes sense. Let's come over here and look at it a little bit more specifically. You see I have red, orange, and brown. Brown goes to the black wire, comes over to the ground rail. The red wire goes to a red wire coming to the 5-volt rail. And then I've got 5-volt rail formed over here going to 5 volts, and the ground coming over here to ground to create the ground rail. And then I've got the bottom leg of the resistor connected to the ground rail. I've got the top leg of the resistor connected to the bottom leg of the photodetector, and that connection then goes to pin A0 on the Arduino, and then the top leg of the photoresistor goes to the power rail or 5 volts, just like I showed you in the earlier schematic. So That's how we're doing it. Now, how are we going to get this thing to work? We got to probably do a little bit of math first. So let me jump over here and do this, okay? Now, I'm going to remind you that the way I have this servo set up, and probably you can set your servo up very easily this way as well, but this is 0 degrees, 90 degrees, and 180 degrees. So what did I do? I wrote a simple servo program. I set the servo to 0 degrees, and then I put the horn on so that it is, when the servo thinks it's 0 degrees, the horn is pointing to 0 degrees. And that's kind of the simple way that I did it. Hopefully that makes sense what I just said. And then now we need to talk a little bit about how we're going to do the math, okay? Now, what do we know? What we know is from last week, and also I guess I should say, if you're not familiar with the servo, go back to lesson number 22 in this most excellent series of video lessons, and that tells you all about using the servo. The main thing is you've got to install the servo library. It does not come pre-installed. I showed you how to do that in lesson number 22. But what we saw last week in lesson number 23, we saw that when the light goes up, the voltage, this A0 voltage goes up. And so when you go from light to dark, you go from very bright light would be something very close to 5 volts or 1023 on the analog read, and as you go from light to dark, you go from something like 1023 down to something close to 0. Now, you're never going to get to 0, but it might be like a few hundred. It might be something very very close to that. Okay, so it'll be very close to that. So how did I do this? Well, I just came in and I did a little bit of math, and I said, okay, now if you remember on the other picture, that full brightness was 0 degrees. And so what would full brightness be? Okay, full brightness would be, let me think about what I am saying here. I think that full brightness would be something close to 1023. So if I read a 1023, that means I'm reading a very large voltage close to 5, and I am reading a very bright light. So if I have a very bright light, I want an angle of 0. So a light reading of 1023 makes me want to have the servo at 0. And you can see that over here, a very bright light would put the servo at 0 degrees, which is here. Okay, I think that makes sense. Then what else do I want? Well, what else I want is that if I have a very dark light, I'm going to be reading 0 volts or 0 on the analog read. And in that case, I want something very close to 180 degrees. So what do I have? I have 2 points. And if I only had full bright or full dark, it would be very easy. But we want to smoothly go from 0 to 180 as the light value goes from 1023 down to 0. Okay, does that make sense? So what do we need? We got 2 points. We need to find the slope. Give me just a second here. Okay, we need to find the slope. Well, what do we know? M, the slope, is equal to y2 minus y1 over x2 minus x1. That is the slope of a line. You should have learned that in about 9th or 10th grade. So what is y2? This is y2. So that's 180 minus 0. That's 180 minus 0, y2 minus y1, over x2 minus x1. Well, what is x2? x2 is 0 minus x1, which is 1023. So our slope is equal to minus 180 over 1023. Okay, and this minus came from right here. There was a minus in the denominator. Okay, does that make sense? I hope that makes sense. So we have the slope. Now what do I need to do? Well, what do I know about a line? I know that the point slope form of the line is y minus y1 is equal to m onto x minus x1. Okay, now y is y, so y minus, I think I'll call this one y1 here. Okay, so you see this will be, I'll call this 0.1 and I'll call this 0.2. You can call either one whatever as long as you keep things consistent. So y minus 180 is equal to m, which is minus 180 over 1023 times x minus x1. And what is x1? That is this 0. Okay, hopefully you guys remember how to do this. So now that's going to be y minus 180 is equal to minus 180 over 1023 times x. And now I can add 180. You're not seeing that. Let me get out of your way. Now I can add 180 to both sides of the equation. So I'm going to have y is equal to minus 180 over 1023 times x minus 0, so it's just x, and then plus 180. So that 180 came over from the other side. So what is my final equation? My final equation is y is equal to minus 180 over 1023x plus 180 degrees. But now we're not dealing with x's and y's. I've got some light val right here. I'm going to be reading something like a light val. Okay, and then over here at the servo, I'm going to need to put it into some position. So this would be light val, and this would be position. So x is light val and y is position. So what would I write this as? I would write this, my servo position is equal to minus 180 over 1023 times x, which has become, x has become what? Light val. And then plus 180. So that is the equation that I need to put in when I program. Okay, so now let's jump over and let's see if we can code this thing up, and let's see if math really is our friend, and let's see if the math actually works. Okay, so make sure that you're looking at, write down that minus 180 over 1023 times light val plus 180, if you don't mind, so you have that there. Very, very handy. Okay, so now let's jump over here to our code view. I need you to fire up your Arduino IDE. I need you to go ahead and open up the bare minimum so you've got what you need here. And then we're going to go in and we're going to start coding this thing up. So the first thing we need to do is we need to pound include the servo library. Remember, it was lesson number 22. I showed you how to install that library. So if you haven't done that, you need to go back and do that. So that's servo.h. And one of the most peculiar times, you don't actually use a semicolon when you're doing an include. Okay, so we're going to do that. And now I'm going to come in and I'm going to create my servo object. So servo, the library that we just loaded, and now I'm going to create my servo. You can call your servo whatever you want. I'm going to call my servo my servo, like that. Don't forget the semicolon. Now we're going to need to set up a variable, an integer, for the position of the servo. It'll be between 0 and 180, but I'll go ahead and initialize it to 0. Now, what pin do we have the servo connected to? And hopefully I showed you that. But if I didn't, sorry. If I didn't, yeah, I showed you on there. But this servo, the orange wire on the servo is connected over here to pin 9. The orange wire on the servo is connected to pin 9. And hopefully I showed you that. But if I didn't, now you know. So I need to go ahead and set up that variable, integer servo pin is going to be equal to pin 9. That's very good. Now also I'm going to have a light pin. The light pin is where I have that photo detector set up, and that was pin what? A0. And we saw that. And now I am going to also have a light val. and that is that number between 0 and 1023 that I read from that pin A0. So I'm going to set that variable up. All right, hopefully that makes sense. I think that's pretty much all that we need to do there. Now what I'm going to come in is I'm in the void setup, and so in the void setup there's a couple of things that I need to do here. I need to do a serial dot begin, notice uppercase on the serial, and that is going to be what? Baud rate of 9600, just because that's the habit that I am in. And then I'm going to do my servo object dot attach. I got to tell it what to attach it to pin 9. No, to servo pin, like that, okay? We're getting our semicolons in. I've been programming in Arduino now for about a week after like 6 months on the Raspberry Pi Pico W, so I'm getting in a good habit now of remembering my semicolons. Okay, now what do I want to do in the loop? I want to read the light value. From that, I want to calculate the position of the servo from our little equation, and then I want to write that position to my servo. So that's pretty straightforward. I'm going to do light val. I'm going to read it. It is an analog read from where? From light pin, like that. Come over. And then now I'm going to calculate that position based on calculate the servo position based on that light valve that I just read. So it's going to be minus slope minus what? 180 divided by 1023. I put a point there to sort of force this to be a floating point number. The integer 180 divided by the integer 1023 would sometimes result in the integer 0. So to force it to a floating point number, the in-between numbers, I put a point there, a decimal point, okay? Now that was what? Times light val, like that. And then what did we do? We added 180, like that. Added 180. There we go. Who's your friend? Mr. Semicolon. Okay. Now that I have that, what do I do next? Well, I'm going to go ahead and print it so that I can see it in case I need help debugging. Print ln, and then I'm going to print position, like that. Okay. And now I'm going to write it to the servo. My servo dot write. What am I going to write? Position, like that. Okay, and now I am going to delay 100. All right, so it's going to read, it's going to calculate an angle, and it's going to write it. So let's see, did you guys see any mistakes in here? I think I was pretty good about my semicolons. Let's go ahead and run this thing and see what happens. It's compiling. Okay, it's looking pretty encouraging. Has no member what? Oh, serial being. It's not a serial being. It is a serial begin, like that. Let's try it again. That was a rookie mistake there. Okay, it's coming down. Looks good. Okay. Looks like it is downloading, and boom. Okay, look at that. We got it without an error. Let's see if we can turn on our serial monitor, and it's saying that it's calculating in here like something that would be full sun. So it's pointing over here. It's something very, very close to full sun, because you got to remember I'm in a studio and I've got like 1, 2, 3, 4, 5 studio lights all around me. So it is very bright in here. But let's see, I can turn off the studio lights, but I'm still in a room in front of a huge window, and it's seeing the bright outside. So if I come like this and I turn it off, you can see my desktop light. It came down a little bit. Let's see if I turn my studio lights off. Let's see if we can do that. Their studio lights is off. It's still seeing the sunshine outside, so it's still doing pretty bright sunshine. But let's say that we have a dark cloud. Let's say that we have a dark cloud come over. And when that dark cloud comes over, it goes to nighttime, or we can go to cloudy, or we can go to partly cloudy, or we can take it away and again be back at full sun, turn this light on and turn this light on, and boom, we're back to full sunshine. Okay guys, just wanting you guys to, I want to kind of just re-establish the learning. I want you to be practicing the things that you learned in earlier lessons. And so last lesson, you learned all about the photoresistor. And then in an earlier lesson, you learned about the servo. And then we've been learning math along the way. And so right now, we sort of brought it all together to have this really pretty slick little display. You could imagine if you had a 3D printer, you could print a nice dial and print something a little bit more elegant than this. So there's a lot of different ways you can do it. But really what I wanted to show in this lesson is I wanted to show you the math, I wanted to show you the servo, and I wanted to show you sort of a practical project using the photoresistor. I hope you guys are having as much fun taking this class as I am making them. Always want to give a shout out to you guys who are standing with me on Patreon. It is my Patreon supporters that keep these new lessons and this fresh content coming. Thank you guys. You can also help me by giving me a thumbs up or leaving a comment down below. And remember to subscribe to the channel. When you do, ring that bell so you'll get notified when future lessons drop. And most importantly, share this video with other people because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.